Alright, so we're still here in 7.1 and we'll derive the law of sine since it's asking us to, and it's relatively quick. So let's look at any old triangle. So there's no right angles in these triangles. I'm just trying to draw a simple one, and I'll call this A, this B, and this C. And so I'll call this little c over here, little a over here, and little b over here. And so I have this triangle that's here in the labeled sides, and we don't know anything in this triangle, so we're just going to solve it in general. So I'm going to drop a perpendicular down here, and so we'll call this height little h. And to derive the law of sines, let me give this another letter, D. So let's look at triangle ADB, right? So where's triangle ADB? Let me come in here. It's this triangle right in here. So that's the triangle I'm looking at first, triangle ADB. I'll come back over here. So what do we know? We know that sine of A is equal to opposite over hypotenuse, which implies, for this triangle, h is equal to c times sine of A. Okay. And then let's look at triangle DCB. So where's triangle DCB? Well, triangle DCB is right here, this green one. So if I come in here and we look at triangle DCB and take a look at a relationship there, come here and just put that in green. From DCB, we get sine of C is equal to h over A. And so what does that imply? It implies h is also equal to a sine of C. Okay, now let's put these together. So with the two, that's the same h measurement. So c sine A is equal to a sine C. C sine A is equal to a sine C. So let me divide both sides by A, and let me divide both sides by C as well. And if I do that, I get sine A over the side opposite it is equal to sine C over the side opposite it. And that's the law of sines. I would get the other parts of the law of sines by changing which way I drew that H. It was arbitrary that I drew it straight down from B. If I drew it straight down from A, I would be able to develop other relationships in the exact same way. And so here's the law of sines. So one thing I want you to see before, remember what I said in the last video. I said that we can apply the law of sines if we know a side and the angle opposite it. Well, that's what this is, the sine of an angle over the side opposite it. So in any triangle, ABC with sides A, B, and C, A over sine A is equal to B over sine B, which is equal to C over sine C. Or the side length over the sine of the angle opposite equals the side length over the sine of the angle opposite it. The ratio could be flipped as well, just like I got when I solved it this way. Remember, I had a choice here. At this point right here, when I did C sine A is equal to A sine C, I made a choice to divide by A and C. What if I divided by sine A and sine C? If I did that, I would have what they have first. So it was just an algebraic choice that I made, and that's why the two are equal to one another. So you would set these up in what would be most advantageous. So if you wanted to ultimately solve for a side length, well, get the side lengths up top. If you want to be solving for an angle, Well, get the angles up top. You can use it however you want. And then they also have the area of a triangle. You know the area of a triangle is 1/2 the base times the height. But remember what we had the heights as. This should not be surprising. In fact, we can show it up here. The heights were like C sine A or A sine C. Remember, it was 1/2 the base times the height. C sine A. Right? We saw that before. What was that? That was H. And so they're just replacing H with that. It's not anything more than just algebraic manipulation with this one observation that we made here using our 2.4 or prior definition of trig functions of sine, opposite over hypotenuse. So when example number 1 is coming from number 4 in there, and they're giving us two angles and the included side. So the question you're going to ask yourself is, can I get the angle opposite, or do I already know the angle opposite the given side? And I don't already know it, but I can find it. I know that the angles of a triangle have to add up to be 180. Currently I have 150, so this must be a 30-degree angle. Okay, so why is that so important? All I need to do is find the length of side A. They're not asking me to solve the whole triangle. Now remember, I want a side length here. I know this side, one of the sides is 10, and I know the angle opposite it. Perfect. I'm set up for the law of sines. So how do I do it? Well, I say to myself, I want a side length. I want the side length of A. So let me start there. A over sine of the angle opposite it. Sorry, that's not 140. That's 45 degrees, not 450. Let me fix that and make that look a little bit better. Is equal to, and then pick the other side that you know, 10 over the sine of 30 degrees. Okay, so they pick something that we know. So this is A over sine of 45 is root 2 over 2 is equal to 10. Sine of 30 degrees is 1/2. So what is that? That would be 2 root A. Hopefully you're comfortable with that. If we fix this side, is equal to 20. 10 divided by 1/2 is 20. And so that is, I'll apologize. I shouldn't have put 2 root A. I was thinking about that wrong. It's I might have said it right. I don't even know what I said. But it's root 2A is equal to 20. Divide by root 2, divide by root 2. And A is equal to, if you rationalize the denominator, you get 20 root 2 over 2, or 10 root 2. That's what A is equal to. You do have the use of a calculator, but when it's like this, we want you to solve them exactly. So don't give me the decimal approximation of A. Make sure it's in its root 2 form when they take time to choose angles that we know, like 30 and 45. Awesome. That's how you're going to do in general problems. So let's see what happens. They're going to have us just solve some ones first, and then they're going to go to some word problems. And so they are going to not shy away from degrees, minutes, seconds. So right away I know, since I'm given two angles and a side, I'm going to be able to use the law of sines, because if I'm given two angles, I can get the third angle if I need it. And so let's take a look at a triangle. I just draw any old triangle. I don't worry about degrees or anything like that being shown accurate. So I'll call this A, B, and C. They're telling me angle B right here is 38 degrees 40 minutes. They're telling me angle C is 91 degrees 40 minutes. And they are also telling me side A is 19.7 centimeters. So there's the labeling in my triangle. I'm going to need that third side because I do not know right away the side opposite A. And even if I did, I would still need to get the other angle because I'm going to have to ultimately solve the triangle. So when they say solve the triangle, they mean get everything. So what are the things I'm going to need to identify? I'm going to need to identify angle A. So in the end, I need angle A. I need the side length of B, the side opposite B, and the side length C. So remember, B and C are the the labeling of the sides opposite their respective angles. Let's go get that other angle. So you're back into like the first chapter and taking 91 degrees 40 minutes and adding to it 38 degrees 40 minutes, and you're going to get a nice 129 degrees 80 minutes, which is really 130 degrees. Sorry about that. 130 degrees 20 minutes. Well, that's the sum of those two angles. Now I got to take 180 and subtract away 130 degrees 20 minutes, or 179 degrees 60 minutes minus 130 20 minutes, and we get a nice 49 degrees 40 minutes. So we've just figured out one of the pieces that we need. Angle A is equal to 49 degrees 40 minutes. So I'll just put all my answers over here. Now we're set. Now you're going to have to grab a calculator, right? Because they're picking obscure angles. Expect that on the homework and in the exam. This is coming from the homework pretty early on in number 12. So let's get, I don't know, let's do them alphabetically. Let's get B first. So if I go get B, little b is what I want. So that's what I'm going to put up top, over sine of the angle opposite it. Well, that's 38 degrees 40 minutes. Has got to be equal to the 19.7. I always stick with the side that's given, all over the sine of 49 degrees 40 minutes. Okay, which is what I solved for. So that's how I needed that in order to get started. As you solve for that, what I would do on my calculator is realize that what B is, it's 19.7 over the sine of the 49 degrees 40 minutes times the sine of 38 degrees 40 minutes. And so we plug that into our calculator. 19.7 divided by sine. Make sure you're in degree mode. 49 plus 40 divided by 60. Close that. Times the sine of 38 degrees, right? Plus 40 divided by 60. Close that and hit equals. And we get a nice 16.14. So B is equal to 16.1. I'll just round it to the same level of accuracy that 19.7 was, centimeters. So now I know B is 16.1 centimeters. So you can see that these are going to take you a little bit of time. Somebody asked, why is the next homework assignment not due until the 4th? Well, because it includes this stuff, and this stuff takes a little bit of time. So now we got to go get side length C. So what we're going to do for side length C, the exact same thing. So since I have the luxury of erasing, what I mentioned earlier is I always want to use the given side length. And so I'm going to stick with this 19.7 all over the sine of 49 degrees 40 minutes. And now when I want to figure out C, it's going to be the exact same thing. That's C over sine of 91 degrees 40 minutes is equal to that. We would do the exact same thing, run it through our calculator, and get a nice 25.8 centimeters in order to save some time. I pre-ran that one. And that's solving the triangle. That's getting all the other missing pieces in it. That's what they want out of that. Sometimes they'll ask us for a very specific thing, and in this case they gave us a picture. In the test, I think I drew a picture next to everything that's verbally described. I'll double check that. So we need to determine the distance RS across a deep canyon. Rhonda lays off a distance TR, 582, and then she finds that T is equal to 32 degrees 50 minutes. And R is equal to 102 degrees 20 minutes. So she knows two angles and a side. This is going to be law of sines, because I can get that angle S opposite the 582 by just doing the 180 stuff that we did before. So we're going to first take 32 degrees 50 minutes, add to that 102 20 minutes, and come up with a nice 135 degrees 10 minutes, right? When you go through that process, I'm going to just truncate this. Then we're going to take 180 degrees and subtract away the 135 degrees, 10 minutes from basically a chapter 1 type of thing for us. And we're going to come up with 44 degrees, 50 minutes when you go through that process. Okay. And so that's the angle S. That's what angle S is. Well, I needed that. So what I know is that I need to find that length RS. So the length RS is opposite the angle 32 degrees 50 minutes. And that's got to be equal to 582 all over the sine of the angle opposite that, which we just found out to be 44 degrees 50 minutes. We didn't know that until we did that big subtraction off to the side. So you can see that the work is way similar from problem to problem. So what's RS? RS is this 582 divided by sine of 44 degrees 50 minutes times the sine of 32 degrees 50 minutes. And so let's take 582 divided by sine of 44 divided by 50 divided by 60. Oh, sorry, I said but divided by, it's plus 50 divided by 60. And then times sine of 32 plus 50 divided by 60. Close that off, and what do we get out of that? We get an RS directly equal to 447.5712 ... So we're going to report the same level of accuracy that was given with the 582. We're going to report the rounded value 448 yards. So even though she can't go across that, because she can get the angle measurements and can measure the side that she's on, she can know the distance across that ravine without ever having to cross it. Okay. We have a few more examples from here in 7.1 that are listed next, and let's just still include them in all these in this video. So, standing on one bank of a river flowing north, Mark notices a tree on the opposite bank at a bearing of 115 degrees 45 minutes. Lisa is on the same side of the bank as Mark, but 428 meters away. Sorry, I wasn't looking at the right thing, but 428.3 meters away. She notices that a bearing of the tree is 45 degrees 47 minutes. All right, so we've got a lot of ideas to look at. So the one thing that they tell us that's interesting is that the two banks are parallel. What's the distance across the river? Okay, so let's take a look. Mark is standing and notices a tree on the opposite bank at a bearing of 115 degrees 40 minutes. So here's Mark, and he notices a tree. Okay. So I'm going to draw this line because the bearing's off of the north-south line, and we got to go 115 degrees off of that north-south line. So I'll just put a 115 degrees, 115.45 degrees. Good, no degrees, minutes, seconds. And so that's the bearing, and he notices a tree right over here on the opposite bank. You got Lisa, she's on the same bank. So here's Lisa. And what she notices is that that same tree is at a bearing of 45 degrees 47 minutes. So off of the same north-south line from where Lisa is standing, it's at 45 degrees 40 minutes. So this is 45, I keep saying 45.47 degrees. Right, that's her bearing. So we got to make proper use of bearings here. So we do know one of the angles of the triangle, and we know that they are 428.3 meters away. Okay, and they want to know what? the two banks are, what is the distance across the river? So in the end, they would like to know this distance right here across the river, the straight across distance that's happening there. So let's take a look at how we're going to find that. Now, we probably could find that in several ways. Drawing that bearing in there, we could use the right angle here. We could go off of the straight distance from Mark and use a right triangle over there. It really just depends upon what your mindset is, and it'd be interesting to see what that is. Now, I decided to just do the straight across distance from Mark. I don't know if that's the best decision in the world. Could totally have worked some other way. What we don't necessarily know, though, actually, is if this line right here directly cuts this angle in half. I think that that's what I was worried about saying. So let's go ahead and find some things that will help us get this straight across distance from M to R, right? From M to the other side of the river. That's why I chose R. So if this is 115 degrees 45 minutes, I got to figure out what this angle is right here. And that's going to be 180 degrees minus the 115.45 degrees. So that'll be faster to do. Sorry, I keep wanting to do minutes and seconds. So 180 minus the 115.45 leaves us 64.55. So this angle right in here is 64.55 degrees, which tells us we can get this other one. So if I look at, if I want to know this angle T, it's going to be 180 degrees, because that's the sum of the angles in the triangle, minus the 64.55 minus the 45.47. So if I look at 180 minus 64.55 minus 45.47, I'm going to get 69.98. 69.98. So if needed, this is 69.98. So again, I was given two angles, kind of. I had to work for the 64.55. I know it included side and two angles. I know it's the law of sines. So let's look at something. The distance from M to T, do you see that there? That distance is this distance right here. The distance MT over the sine of the angle opposite it, which is 45.47, has got to be equal to the 428.3 all over the sine of 69.98. And if I run that through my calculator, it's going to give me an MT value, and I pre-ran this, of 324.9645. I'll go out that far. And the reason why I'm keeping that one out is I don't care what MT is. I'm just using it as a help. I'm using that as a help to figure out what MR is. So let's take a look at where MR is. So let's make sure you see where I'm talking about with MR. That's what they're asking us to find, that straight across distance. So MR over 324.9645, okay, is equal to the sine of 64.55 degrees. Do you see how I'm getting that? I'm not using the law of sines. Maybe you expected me to do that, but I don't need to. This is not an oblique triangle. It's a right triangle. So where is 64.55 degrees? That's right here. This angle right here, because I have two parallel lines. How do I know they're parallel? Because they tell me they are. Is crossed by a transversal. The alternate interior angles are equal. So this is 64.55 degrees. So 64.55 degrees has to be there. Now you could also have found it by figuring out what this angle is by taking 90 minus 64.55 and coming up with the result of that. Well, this has got to be 90 minus that result, or 64.55. So it makes a whole lot of sense. But I'm just using that the sine of this angle is the opposite over the hypotenuse. And I just figured out the hypotenuse was 324.9645. So we're using a chapter 2 technique. So what's the distance from M to R equal to? Just like you did in the previous sections. Sine of 64.55 degrees times this 324.9645. And if we do the sine of 64.55 times 324.9645, we get 293.4. So the straight across distance across the river, no matter which perspective, is 293.4. Again, I'm going out to the tenths because they gave the 428.3 number out to the tenths, meters. So I can get that distance across. So this video is getting a little long, so I'm going to do the last 3 examples. Oh, actually more than that. So yeah, I definitely should cross it. I'm going to do those last examples in another video.